few words about these different biofuels that we cover now. So I'll go through some of these most common biofuels and then on Wednesday a little bit about more these properties and sustainability aspects, but that's how I have thought that it would go this time. So this is something very, very general. We have already gone through similar things, but you can of course group or categorize the biofuels in depending on various parameters, and here is just one. So if it's the state of the fuel, so if it's solid or liquid or gas, but you can also categorize it in based on, for example, what chemically the material the fuel is made of, like is it, for example, made of fatty acid esters, or is it like alcohol, or is it something like a hydrocarbon branched one or aromatic one, and so on, depends. So chemically it can be like that, and there are other possibilities to group or categorize these biofuels, of course, based on application, based on the processes that are utilized to make them. So is it like based on fermentation or microbiology, microbial activity, or is it based on chemical reactions, or is it based on like this thermal processing, degradation or breaking of the polymers and so on. And like I said in the introduction already, so biofuels are organic molecules, and you can make organic molecules from different starting materials so that the reaction routes are vary, but you end up with the same product in, for example, this ethanol, so ethanol. So you can make it based on fermentation from glucose, from sugars that come from the biomass, or you can also make it from the fossil-based materials like ethylene that is normally used to make polymers, polyethylene, but you can hydrate, so add water into the ethylene to make ethanol. It requires certain conditions, certain catalytic materials and so on, but it's maybe not the most common way to do it, but it can be done. So it's an example that you can make ethanol at least with two different chemical reactions starting from different starting materials. So here I don't have much information on the slides, but I hope that you did the pre-assignment and already glanced through these different websites or the links on this website, so that you have a slight idea what kind of information is provided in there. So I will not go through all that what you can find on behind these links, so feel free to utilize this info on the website, and on our course materials also contain a lot of information about common biofuels that are covered during this course. Solid biofuels, so that is some examples. You'll see here this woody material, and then here is some crop material like maize and wheat, grain materials and such. So basically, at least I come from Finland, we use quite a lot of wood, like on this right hand side here. So if like logs for heating, these can be grind to or processed into some kind of pellets or granulates that are used in boilers or heaters to make basically heat or heat and electricity. So that's kind of a traditional way of releasing this bioenergy stored in the biomass or woody material. And if we think about biofuels in general, so these solid materials are not really, it's more like the starting material, so or the raw material for making those biofuels. So this solid woody biomass, it's not really the end product, but you'll convert it to something. And the most useful products are like these transportation fuels, typically liquid biofuels, or in some cases also gaseous biofuels made out of this solid lignocellulosic material. And I purposely selected the edible parts here in the picture because these are not the preferred starting materials. You want to use the non-edible parts or the leftovers or residues, so typically like peels and stems and some parts of that edible plant that is not typically eaten, used as a nutrition for humans. I have here more or less the same headings that we had on our this material or that web page that I showed. So there is a group of there are alcohols that are common biofuels, and here is methanol that is used, has been used long time ago as fuel already, and previously, or it can be made from natural gas or purely fossil based materials. So here also is the possibility to make the same chemical from natural gas based materials, so basically fossil materials, or it can be made from the carbon source, could be biomass or lignocellulosic material. So you end up after gasification to synthesis gas, and that can be then converted to methanol. So basically it's the same process, it just uses biomass as a starting material. Of course, there are always small variations in these process conditions and potential catalytic materials and such. So, but in principle, it's very roughly totally the same process. It doesn't matter if you use fossil-based carbon source, natural gas, or if you use biomass. So it's quite the same. And for that assignment, so I would like that you list more or less all of these fuels and collect under each heading the properties and applications and information related to these particular fuels, so that you get to know the most common ones. The drawback, like I said, so I will not go through all the details regarding methanol. There we have links and material for that. But it's good to maybe know that previously methanol was used more as a fuel and also, but it's quite toxic. So that is one drawback with methanol. So therefore, this ethanol is less toxic alternative. It has similar properties as methanol, but any case. So we move on. Bioethanol. So that's already mentioned few times. So the most common way to do it is the same way that we produce alcohol drinks or alcohol beverages. So it's basically the same process as making beer or spirits. So there is the breaking the biomass into sugars, and then the resulting sugar is fermented by yeast or microbes, typically like baker's yeast does the job. And then you'll get the diluted aqueous solution of ethanol and water, and CO2 is also produced in that same process, but that as a gas escapes the vessel or the container. It doesn't stay there typically, but that is not yet good as a fuel, so it has to be purified or the water removed. Usually it's removed by distillation, and if it in fuel grade, it also requires perhaps some molecular sieves to make it even more pure ethanol. But this so-called first generation bioethanol, so it's in any case made from edible materials, so the same materials that we make alcoholic beverages. Then the so-called cellulosic ethanol, so the production process is different, but of course the end product ethanol is always the same. So that's the name of the molecule or the chemical. It doesn't. It's totally the same if it's from grain or regular sugar, or if it's from based on cellulosic material. This picture is not maybe the most representative one, but I couldn't find easily better pictures. So what's the difference here? The second generation bioethanol, so it's made from lignocellulosic material, so wood waste or plant residue. These parts like the stem or leaves or bark or parts that are usually not used, so are kind of side products, or at least these are not edible parts. So we'll take a look at these processes then later on. So this is just the introductory part of the course. So if you are wondering, so we don't go now into very all the details of the process and so on. So that comes later on. So this is one of the, like, bioethanol is one of the most famous, perhaps, if you ask somebody, like, do you know some biofuel? So it's either bioethanol or biodiesel, and those are the most maybe common ones that everybody has heard is mentioned somewhere. Then what? This is all this so far have been alcohols. So chemically, for a chemist, so alcohol means that there is a hydroxyl group, or it's OH group in the molecule that makes it an alcohol, the structure. So this is very analogous to ethanol. It's just there is just a longer hydrocarbon chain in this. Butanol has 4 carbons and ethanol has 2. Methanol has just 1 carbon in it. And this is already much better fuel alcohol than, for example, ethanol or methanol, because biobutanol, I might have here the table, but later on anyway you'll see it. So this resembles much closer to gasoline or petrol in terms of properties, and also this butanol has already lower water solubility. So, like, the only highlight that I took here, so you can more or less put the butanol into existing distribution networks, so it works quite well together with gasoline or petrol. So that's the good thing with it. The problem with this, one of them, is that this is not that readily available, and it's also expensive than ethanol. But on one hand, it's as a fuel, it's better, much better than ethanol. This can also be made through chemical route, so you can combine, I think, 2 ethanol molecules with so that you'll end up with butanol and something else. Or then there is this kind of fermentation route to biobutanol. You end up with acetone and butanol, so you make 2 basic chemicals in the same process, but they're what I have understood. So it's a very old process, already over 100 years old, and the yields are quite low in this microbe-based biobutanol process. But in any case, it's an interesting molecule. I have also, some 15 years ago, made few articles about this, how to convert ethanol into butanol using different catalytic materials and so on. So dimethyl ether, is the next biofuel, and it's basically, if we have bio-based methanol, so we convert it, we react it further and do dehydration. Dehydration means that removal of one water molecule, so you end up with this dimethyl ether structure that is like you see here. So it's in practice a gaseous biofuel. So it's but in any case it can be used in cars, in transportation, as a bio-based fuel. And like methanol, so it can also be made, or this can be made fossil based or bio based. Biogas or biomethane, that's probably, I don't know if it's familiar to you, but it's basically something that is created in anaerobic digestion of process of. So for example, in sewage sludge, so if it's in anaerobic conditions, microbes start to make biogas, roughly mixture of methane and carbon dioxide. And also the same processes happen in, for example, landfill. So if you put organic material into landfill, so eventually there becomes these anaerobic conditions suitable for methane or biogas production, and it starts to make this biomethane biogas mixture. And already for tens of years, I think the biomethane generated in landfill sites so has been collected and used. So it has been used locally for making heating or making of electricity, at least here in Finland. And the reason is not maybe the energy recovery, but it's more like that the released methane is quite potent greenhouse gas, and it's beneficial for the climate to recover it and use it instead of releasing it in the atmosphere. So, but if you have organic waste or food waste or manure or sewage, anything organic, and it starts to produce biomethane quite easily under anaerobic conditions. So hydrogen is a good fuel, and it's used a lot in chemical industry, in petrochemical industry. So it's important basic chemical. It can be made for example, based on steam reforming from methane or biomethane, natural gas, and so on. So that's one example of biofuels. Again, this is clearly gaseous, and we are not focusing on this during this particular course, but I think we go through the process still later on a bit. Then there is listed on the web page bio-SNG, so synthetic natural gas. And here the production process is slightly different, but it anyway makes methane as a product. So it's through gasification process, not through anaerobic digestion process. So the chemical or the processing route is different, totally different type of equipment. And also the starting material is, well, it can be different or more or less similar. So cellulosic material refers to these wood-based materials, and we'll talk about those in the section C. But woody biomass is basically composed of three main ingredients or components, and one is cellulose that is often extracted in pulp and paper industry. So it's made, you make paper out of cellulose, but the woody material contains so-called hemicellulose. It's often quite soluble, so it can be extracted easily out. And then there is the third component called lignin. So lignin, hemicellulose, and cellulose are the main components of this type of cellulosic woody biomass. Okay. Are you familiar with this ETBE?
No.
This is a gasoline additive that is added into gasoline nowadays. So it's previously it was MTBE, so it's methyl terbutyl ether was used, but that had some problems with the too high water solubility and polluting of, or if there were gasoline leaking from the fueling station and it ended up in the groundwater, so MTBE pollutes really heavily the groundwater resources. But let's say the second development or improvement was to, instead of using methyl, so using ethyl terbutyl ether, which is not much less water soluble. So this is not such an potent pollutant for the groundwater. And nowadays it's added in the gasoline instead of MTBE. And what makes it bio is that, of course, if you use bioethanol making the ETBE, so then it's a bio-based fuel ingredient or fuel component. Do you have any questions at this point, or this all should be clear to you if you have done the pre-reading assignment, so that there should not be anything new. Okay, maybe I can stop here. I think we'll have a short 15 minute. Let's continue in 15 minutes. So I don't have very many slides for today because, like I said in the introduction, I thought that we could go, or you could do the second assignment or start to do it already, and I can be online helping you if you have questions. But now, so a 15-minute break, and then we'll still continue for maybe max half an hour. These fuels, different fuels. Sergio, do you have question or?
Yes. I'll try to switch on my camera. I have to be honest, I had a look on the web page of the master during the weekend, but I don't find it very easy, very friendly. And I was wondering if we can go through very shortly again on these study materials and this task. Is it the only one? It's the only 3 questions we have to answer for the assignment?
Yeah.
Okay.
But we can go through those still if you want. So you want to go through the assignments or all the materials that are in
or both? I don't know. I don't want to put pressure on this. Open to the requirements of also other colleagues. I don't know what they prefer to do. I wanted just to be sure that they are the 3 questions we have to work on. I have to be honest, I didn't have time to study much in detail the material, so I spend my time saving and organizing all things.
Yeah,
know
no.
what other people thinks about, if they prefer to take a break or if they would like to have more indications. There are no many
having the indications maybe could be useful for all of us, I think.
I agree. I mean, I'm happy to spend the break to understand better what kind of expectation you have to answer the questions.
Yeah, okay. Okay, so previous slide was this ETBE, ethyl terbutyl ether, and sorry that I usually draw these molecules if they are like simple as these are, but now I had some problem with the ChemDraw drawing program, so I for some reason I got a new computer and I don't have rights to install the program, so I hope it's possible for me quite soon to start drawing these structures. So I think at least maybe, well, since I have a chemistry background, so at least for me it's visually much clearer than only playing with these names here. But it comes hopefully. So the next biofuel is this biodiesel, and there are essentially like two types of biodiesels, and this so-called FAME, fatty acid methyl ester. So this is the more primitive one. So in technical terms, in quality and in properties, so this is not that advanced. So it's quite simple to make. You'll mix just alcohol and the fats or lipids and add some base or acid, and then you end up with this product, the FAME, fatty acid methyl ester, and it can be used in diesel engine, and typically, like I mentioned in the introduction, so it's used just as an additive. So the modern diesel car doesn't run with pure 100% FAME. It might end up breaking the engine. So, but this is just used as the biocomponent or bioadditive. But very often when people talk about biodiesel, so they'll talk about this particular chemical. And this was originally so-called first generation biofuel. So it was more or less made from these edible oils, rapeseed, palm oil, soy oil, and so on. And of course, it can be made from some waste fats and waste oils, but in any case, so like I said, so it's not. There are better alternatives, and the better alternative is this HVO, hydro-treated vegetable oil. So this is called, if that other one was called FAME or biodiesel, so this is by purpose called renewable diesel. So it's chemically totally different. So this resembles the fossil-based diesel. So it doesn't have this ester structures like that FAME has. So this is much more, it's higher quality product. It can be fed 100% into normal diesel cars, and it runs. It's even better quality than the fossil-based diesels. The production process is more complicated, and it's totally different chemically. So there is the hydro treatment. So it's treated with hydrogen and in the presence of catalyst. And what it basically does is it removes the oxygen atoms from that fatty acid esters. So you end up with the long hydrocarbon chains, which are the structures that are in normal diesel as well. And therefore it's better in quality. And then this biomass to liquids or Fischer-Tropsch liquids, that's something that we deal also during this course or go through in more detail later on. Fischer-Tropsch process is very old, already before Second World War, German invention, and I think it became popular in Germany in the war times because they didn't have good access to petroleum or crude oil, but they needed fuel for the vehicles during the wartime. So the Fischer-Tropsch process was very useful because they had coal or solid carbon reserves in Germany, so they could liquefy the coal in principle and convert with Fischer-Tropsch process that synthesis gas, that produced synthesis gas to hydrocarbon chains or fuel type hydrocarbon liquids. And in that time it was mainly used to process coal, but it works with biomass, and that has been studied now for some 20 years at least, quite actively, and also we'll take a look at that later on. And this was a good reminder to me. I already mentioned this last time to you. So that straight vegetable oils or pure vegetable oils. So in principle, these simpler diesel engines, particularly the older ones, so those originally were designed so that they'll run with the regular vegetable oils. So this can be used as fuels. So modern engines need engine modification so that they can burn or run with these vegetable oils, but in principle, so these are as such fuels or can work as fuels in certain type diesel engines. So this is example of a biofuel that has not been processed really, or it has been processed to minimum level, as it is just the vegetable oil, and you'll fill that into your vehicle, and no other chemical or physical processing is needed. But of course, this is not the best in terms of quality and many other properties. So then we come to this. I think this was the last, more or less last on the list, synthetic hydrocarbons, or also one can call it drop-in biofuels. So these are the most latest addition to the biofuel possibilities, and this is something that we touch more in this Power to X course. So it's basically, there are two elements when making these. So it's carbon CO2 capture. So you capture the carbon from the, let's say, exhaust gases or from the air, and then you capture the energy from wind power or solar power, and you combine, or you utilize the free renewable electricity to break water into hydrogen and oxygen, so electrolysis. And when you combine the hydrogen and this captured carbon dioxide, so you can convert those into these hydrocarbons, so organic molecules. But this is still very much at research stage, or maybe some small piloting experiments are being done. So it takes time for this to become everyday product for consumers. Okay, there was still bio oil. Bio oil is based on biomass or woody biomass, and it's made with pyrolysis, not with gasification. So you heat up the biomass, and you, depending how you treat what type of conditions you have, you can get vapors, you can get liquids, you can get solid material. But this bio oil is more or less the liquid fraction coming from the biomass pyrolysis process, and it has hydrocarbon components, but it is quite, it's well suited for heating, like for burning for energy purposes or heating purposes, but as a fuel in cars, so it typically requires some upgrading, purification, and improving the quality of the bio oil. So, but it's a bio fuel that has been studied a lot, and we'll also take a look at that production process in the coming lectures. So I think that was all of the different biofuel alternatives that were part of the pre-reading material. Well, I will not go through much this particular table details, but here are, in general, when talking about fuel properties, so here are different fuels, and then some properties that are listed, like chemical structure, number of carbons, density, viscosity, octane, cetane number, heating values, flash point, fuel equivalence, and so on. But of course, there are lots of other properties as well. This is not very in any complete list of these properties. Octane number is for gasoline, and cetane number is usually when compared to diesel fuel that we covered also last week briefly. This is still something that we haven't touched very much. So classification like this adds little extra what we have already discussed. So you can group or categorize biofuels as primary. So it's basically that biomass that you burn or combust to energy, perhaps electricity. And then secondary ones are such that you'll process a bit further so that the biomass is just more or less the raw material. And these biofuels have been long already categorized as first generation and second generation. Nowadays you find also third, in some publications even fourth generation biofuels, but I think these definitions vary, so it's not always the same ones, for example, in that box or third generation category. So, but it's quite clear that this first generation refers to this biofuels that are made from edible foods, edible biomass. So basically oils and fats, and also like sugar containing materials, those that have been used to make ethanol, make alcoholic beverages. So it's something that is normally, it's better to use for human nutrition or human food instead of making fuels. And then the second generation ones are like in here, the lignocellulosic biomass is the starting material, but sometimes also I think here can be listed this non-edible biomass or plants that are not or eatable, or some residue from the food processing or pulp and paper industry or forestry. So the parts that are not are kind of waste or leftovers, and those I think also can be called second generation biofuels if those are used as starting materials. So here the bioethanol or butanol via enzymatic hydrolysis, and then also it's mentioned quite many of those things that we study on this course. So methanol production, Fischer-Tropsch, and so on. Here the third generation refers to use of algae or seaweed as the biomass raw material. Biodiesel from algae, I know that it has been studied quite a lot, but there have been technical difficulties, and it's not, I think, I'm not sure who is producing it at the moment. So for example, this Finnish oil refinery Neste, they studied quite a lot this algae and tried to extract these oils and useful chemicals out from algae, but it never reached this kind of more than piloting stage. So I'm not sure what was the problem. Was it too expensive or I'm not sure, but algae has a very good potential being a useful biofuel raw material, because algae produces quite a lot of oils in the cellular level. So that's just the trick then to make the algae grow. It usually needs the sunlight and proper conditions, and then you have this tiny single cell algae rich in oil, but you still need to process them or extract somehow the oil and then convert that into something useful like biodiesel or other biofuels. Here's one table so that the benefits and challenges. So there are more dimensions than just what I have dimensions than what I earlier mentioned. So like energy security that we already discussed at some point. So that's a clear benefit. So if you have something else instead of fossil fuel or fossil-based energy, so that of course is politically also safer, or it adds to the energy raw material possibilities. So these biofuels can be like domestic energy source, locally distributed, higher reliability, at least in some cases. It's also mentioned well connected to supply-demand chain. On the challenge side, so collection network, storage facilities, food fuel competitions is kind of problematic. Then economic stability. So here it might boost the rural developments and open new industrial dimensions, for example. And there is always the comparison to the current fossil oil refinery industry. So this is kind of an alternative to that. The technology exists, but it's kind of on the problematic side. So it usually tends to be expensive than the existing oil refinery processes, processing fossil starting materials. If we talk about this second and third generation biofuels, so there has to be quite a lot of so-called pre-treatment so that this biomass components can be accessible to those microbes or to the processes. So it's not that easy to convert those into fuels and so on. There are technical difficulties in that. And here lower left corner, of course, these environmental gains are on the benefit side. So reduce pollution, greenhouse gas emissions and so on can be benefits of biofuels. Of course, there's a lot of debate and discussion, so that it's not also that straightforward that if it's bio, it doesn't always make it better than the fossil ones. So one should carry on these life cycle analysis and calculate the whole production process from collection of raw material and making product, and also logistics included, before making these conclusions that bio is better. A lot of policies involved, and yeah, it's of course those are kind of new processes, so there there is also always new challenges when it comes to the policy, and legislation is lagging sometimes behind. So processes are developed faster and then legislation follows, and it can generate problems, because if you already invested in your production facilities and soon the law makes it illegal, so that's of course a drawback, makes things very challenging. Okay, I have the more or less the same info here. Here's also, like, you can just compare if you are interested in. So here is a graphical visualization that has from first to second, third, and even fourth generation biofuels defined. So don't know if it's, for example, here third generation biofuels, so it refers to CO2 capture and perhaps these power to X applications, how it was here. Here it was like algae and seaweed, more or less the starting materials. So, but the second generation is more or less the same here. Organic waste, agricultural residue, wood, so lignocellulosic biomass converted to products. This is maybe something to consider, that I think this disadvantages side is limited amount of biomass. So it is just a fact that we talked about this already, or I mentioned it, that the oil volumes that we consume are huge, and it is difficult to compensate with just one type of bio or alternative energy. So therefore it's like we don't have so many forests, so many fields, so much, let's say, agricultural residues that we could compensate the oil consumption. So there are clear limitations in one single method. So then I mentioned that we need all these renewable things, and still I think we struggle to compensate the oil, coal, natural gas utilization. So that's a real problem. Okay, these are not supposed to be here. Sorry, I need to remove the only why this is the more or less the last slide. The availability is also part of this sustainability thinking, but this table here reminds you or us that there is, when talking about these biofuels, this is now just an example. So there is more of these numbers in the course book, but there is always like this certain yield, like per hectare, or what you can get out from that particular plant or biomass source. So the oil well is producing more or less constantly or crude oil or natural gas until it runs totally empty. But this biomass production is more or less dependent on sun and the growth period. And here up in the north in Finland, so we have just the summertime, and usually the plants grow the fastest in spring. and end of the summer, so there is very little growth. So there are huge seasonal variations. So we get crops once a year. So if we are dependent on biomass, so it can be that we'll get just a very huge amount of it once a year, and the rest of the year we have to manage with our storage, and that is not the case with oil or natural gas. But that was just one aspect of biofuels. We'll take a look at, in that course book, there is one chapter for the growth rate and product yields and such kind of things. So those are quite important to take into account.